We have a 55-gallon barrel that contains a mixture with a concentration of 35%. So this could be 35% of anything, saline, whatever. How much of this mixture must be withdrawn and replaced by 100% concentrate to bring the mixture up to 70% concentration? So let's go ahead and set this up. Once again, we're setting up a linear equation and solving for x. Okay. So if you can imagine, we have a barrel. Right, we should always draw pictures, or at least I try to attempt to. Okay, we've got a 55-gallon barrel, and it contains a mixture with a concentration of 35%. So 35%, I guess you could say, right, 35% of this stuff, whatever this is. Now let's say the barrel's full. But we're going to replace this, right? It's asking how much of this do we need to take out of the barrel. We have another barrel over here that is 100% concentration. Okay, so this is 100%. But this barrel only contains 35%. Now, it's not 35% full, it's just 35% concentration of whatever this possible chemical could be. All right, but we're going to take some out, and let's not let it drip out here onto the ground. And then we're going to take some out of here, and then we're going to take what's in the 100% barrel, right, and replace it. Okay, we want to bring this up to, we want to bring that up. Let's go ahead and just erase this. We want to bring this up to a 70% concentration. Okay, we want to bring it up to a 70% concentration. Okay, so this is what we're going to do. We're going to let x be the unknown, okay, amount, and we're going to take, so what should I write down here? So 35% of x, see this, 35% of x plus 100%, now 100% is just 1, okay, 100% is just 1. Now, we have a total of 55 gallons, all right, 55 gallons. But we're going to subtract off x. It's going to be equal to, we have 70% concentration, so 0.70 times 55 gallons. Okay, 55 gallons. So 70% of 55 gallons, right? Okay, now once we have set up our equation, we want to simply solve for x, which is pretty easy to do at this point. So let's just rewrite. Plus 55 minus x is equal to, and 0.70 times 55 should give us 38.5. Okay, collect up our like terms. So 0.35 minus 1 gives us negative 0.65. X is equal to, now what you want to do is subtract 55 from both sides. I think of it as just taking that over. So 38.5 minus 55 All right, so 38.5 minus 55 is negative 16.5. Go ahead and rewrite. Okay. You can multiply through by -1 all the way across. This gives us a positive. Or you could just do this. 1 over, you could say negative, if you wish. Alrighty. So we're left with x is equal to, so we have a negative on top times a negative, negative times negative is positive, 16.5 divided by 0.65, all right, is going to give us 25 point. Now we're going to need this number, so that we don't get round off error, I'm going to go out 25.3846. Go out to 4 decimal places. Good enough? Okay. Now, we're not done. Okay. What did the problem say up here? It says how much of the mixture must be withdrawn and replaced by 100% concentrate. Okay. So you're going to take the 55 gallons and subtract off 25.3846. Okay. And that's going to give us, actually, let's do this. Let's write this below here. Equals 29, and we'll go ahead and round this one here. Okay. So 29.62 gallons. All right, how much of this mixture must be withdrawn and replaced? All right. Okay, so this stuff's pretty useful. If you've seen the last problem, we were mixing coffee beans. I mean, look at this. So this is extremely useful right here. We're breaking up two things and mixing them together. All right. You can try to come up with your own problems. All right, see you, I'd say see you in the next one, but I think this is the last one actually for applications for a while. See you in the next section on quadratic equations.